Okay, here's a titration problem from Alex. And so I think we can do these. It's talking about titrating sodium hydroxide with a diprotic acid. So let's read the problem here. So a chemistry student weighs out 0.885 grams of vitamin C, which is ascorbic acid, which is a diprotic acid. There are two H's there, is what's going on, into 250 mils of a volumetric flask and dilutes to the mark with distilled water. Here is the molarity of the sodium hydroxide he's going to titrate with. Remember, you guys did some titrations in lab. So calculate the final volume of sodium hydroxide solution the student will need to reach the final equivalence point. Well, this is a base, sodium hydroxide. Ascorbic acid is a diprotic acid. And so we can write an acid-base equation here. So we have our sodium hydroxide plus the ascorbic acid, which is H2, and I'm just going to write ASC for this thing right here, the ascorbate ion right there. So we have sodium hydroxide plus ascorbic acid, and we know that all acid bases give us water plus it's going to give us the salt, which is going to be Na2 ascorbate, so sodium ascorbate here. So how do I know it's Na2? Well, because there are two protons there, this ascorbate ion has to be a -2 charge. So let's balance these things out. So I have 2 sodium hydroxide there, I have Na2 ascorbate there, and then I think to finish that out, to totally balance that, that'd be a 2 right there. So I have 2 oxygens, I have 4 hydrogens, 2 sodiums, and an ascorbate. Alright, so there's my chemistry that's going to go on right there. And so we start out with this amount right here. I never start with a conversion factor. Okay, and our conversion factor that we're going to be useful here, remember that big M? I hate the big M. So whenever I see something like that, I'm just going to write this as a conversion factor, 0.1500 moles per 1 liter. Okay, so now we can start out this problem. And let's start with our ascorbic acid and work our way to sodium hydroxide. So I start off with 0.0885 grams of ascorbic acid. Okay. Now I gotta convert those to moles. You guys know that by now, and so I look that up and I see that there are 176.12 grams in 1 mole of the vitamin C, or the ascorbic acid. Okay, now what am I trying to go to? I'm trying to get to this volume of sodium hydroxide. So I come back and I look at my chemistry up here. And I know that for every 1 mole of the ascorbic acid, I react 2 moles of the sodium hydroxide. So for every 1 mole of the ascorbic acid, I react 2 moles of NaOH. Alright, but it's not asking for moles of sodium hydroxide, it's asking for the volume. I think it's going to ask for it in milliliters. And so I can use my conversion factor right here of the molarity, because I know that there are 0.1500 moles for every 1 liter of sodium hydroxide. And it's asking for a volume in milliliters, I believe, so I know that in 1 liter there are 1,000 milliliters. So let's go back and check units. Grams of ascorbic acid are going to cancel. Is this a true statement? It is. There are 176.12 grams in 1 mole of ascorbic acid. Do my units cancel here? They do. Is this a true statement? Well, I get this from my stoichiometry. For every 1 mole of ascorbic acid, then I do react with 2 moles of sodium hydroxide. Do my units cancel here? They do. Is this a true statement? Well, it gives it to me in my problem. There are 0.1500 moles in 1 liter. And these cancel, they do, and this is a true statement. So when I do all of that math, I get 6.70, 3 sig figs. So 6.70 milliliters sodium hydroxide are needed to fully titrate this thing out. That is, to move all of the reactants to products. Okay, that's how you solve that problem.